Hi, this is Dan Bullard, retired electronics engineer. Couple things going on. I'm out here on the front deck of my houseboat again. I'm breaking in a new computer, so we'll find out. I'm using DaVinci this time, not iMovie, so we'll see how this works out. The last video that I did, or the second last one that I did, was kind of exciting because it showed that I could prove that what I was doing was happening in real life. And you know, the pattern that comes off of the Bullard Harmonic solution, when the phase angle varies, it makes a really interesting pattern. And it's based on the Bullard Harmonic solution. I'm sorry I can't give that away, but that's just the way it is. But I want to let you know, brand new, I introduced a new law to physics, because it was pretty obvious to me from that one video that I was like, I'm just, you know, I think the way that I think, and I forget that people don't remember how to think the way I do, or don't know how to think the way that I do. When you have reciprocal angles, and I tried to make a video about that, when you have reciprocal angles, so like 60 and 240, right? So they're reciprocal, right? So if you're pointed at 60 or 240, you're basically pointed the same way. They're just, you know, opposite directions, you know. And that's the truth. That's the way that the spectra work. Spectra from two events that are identical in inverse phases, in opposite phases, those two events, the spectral signature will be identical. And so that's what I decided. I might as well, you know, I know that in my head because I know the Bullard Harmonic solution, but you may not, because you may not have bought my book, or who cares. But, you know, rather than giving the book away, I've thought, well, let's make a law. It's pretty, I say it in distortion anyway. When I talk about square waves, and you start with a 50% duty cycle square wave. 50% duty cycle square wave has a spectrum that looks like this. And when you make the duty cycle 51% or 49%, then you get a spectrum that looks like this. So it doesn't matter whether it's 51% or 49%, it's the same thing. It's one away from 50%. So they're opposites. They're inverse angles. They're inverse phases, or duty cycles. So they're basically inverted, but the spectrum looks identical. So as long as the angle, and you know, I'm sorry that I haven't like said this out loud, but it's kind of, it comes from the Bullard Harmonic solution. I'm sorry I didn't tell you that. So I'm going to tell you now. So Bullard's laws of harmonics number 6, the harmonic signature will be identical for distortions that happen at the reciprocal angle in the wave. Okay, so if I take, you know, let's say 6 degrees. If I do distortion at 6 degrees, I could lop off the top of a wave at 6 degrees. And then I go and do the same thing at 240 degrees. The spectral signature will be identical. Now, I've shown this a number of times, and in my book Distortion I show it quite a bit. So I kind of get used to the idea that you know that, but you may not know that. So, you know, if you have reciprocal angles, right? So if you clip the top peak and the bottom peak at exactly the same reciprocal angle, I say, you know, in my previous video I say the same angle, but it's not the same angle, it's the same reciprocal angle. And so that's what I really meant. But anyway, so if you chop off at 60 degrees and at 240 degrees, you'll get exactly the same signature. And I've shown that again and again and again. But the thing is, you may not realize that. And so I thought I'd better make a law to like codify it so you understand it. So I hate making more laws, but it's just the way it's going to have to be. You're just going to have to deal with more laws. So law 6, the harmonic signature will be identical for the distortions that happen at the reciprocal angle in the wave. Just so you know, I don't always remember what you don't know. And Sorry about that. I do my best, but I forget what you don't know, and I've done this for years, right? I wrote distortion. I wrote I did the Apple Coast video back in 2014, right? It's 2022 now, so I've been doing this a long time. It gets kind of ridiculous at times, but I'm still doing it. I don't know why. So, From the River, this is Dan Bullard.